For the last couple days, we've been dealing with exponents. Now we're going to work a little bit in reverse using something called radicals. You know that 2 squared is 4, 3 squared is 9, 4 to the second power is 16, and 5 to the second power is 25, and you could go on and on and on. You know that these are called perfect squares. The numbers that you see are called perfect squares. This is a perfect square. 9 is a perfect square. 16, 25, 36, going on and on and on when we multiply a number by itself. But now what we're going to talk about is radicals. This is a name for this symbol, the square root symbol. That's called a radical. And the thing on the inside is called a radicand. Now, that's kind of highbrow math, and you really don't need to use it, except that you need to kind of know it in the back of your head, but you're not going to be using it in this class. Just know that the number that's on the inside is the radicand. Now, when we see a square root sign, what we're trying to do is we are trying to find out what number times itself will give us 4? What number times itself will give us 9? What number times itself 16, and so on? Well, basically what I'm saying is if I give you a square that has 4 blocks, what would the length of each side be? And we know that the answer would be 2. So the square root symbol, the radical, is the opposite of squaring any kind of term. Square root of a product is equal to the product of each square root. So basically what we're saying here is if I have a number inside the radical, I can break it up into 2 smaller factors to help us find out what the square root is. There are no perfect square factors other than 1 in the radicand when we have simplified it. The radicand is not a fraction, and the denominator doesn't have a radical in it. It doesn't have a square root sign in the denominator. So we're looking for perfect square factors. We won't have any fractions, and there won't be any square root symbols in a denominator. So here's what I mean. If I want you to simplify the square root of 12, the first thing I'm going to do is I am going to look for perfect squares inside the number 12. Well, you know what? I'm really bad at multiplication and I'm not really great at factors. So what if I do 2 times 2 times 3? Well, that'll help because now I know that I have the square root of 2 times the square root of 3. Well, the square root of 2 times 2 is the square root of 4. And I know that the square root of 4 is 2. The square root of 3, I don't know what it is. I know it's 1 point something, 1.2 something, but we leave it just as it is. Because for these exercises and for this particular section, 2 raised up to the 2 times the square root of 3 is as low as we can go. Looking back at the directions that we had for simplifying, this is a whole number. There's no perfect squares inside 3, and it's not a fraction. Let's look at another one. I'm trying to find out what the square root of 8 is. So the first thing I think of is which one of those perfect squares that I talked about on the first page, 4, 9, 16, 25, which one of those is a possible factor inside 8? Well, I know that I can break 8 up into the square root of 4 times the square root of 2, because 4 times 2 equals 8. I know what the square root of 4 is. The square root of 4 is 2. And the square root of 2, there's nothing I can do with that whatsoever. So my final answer is 2 times the square root of 2. And I leave it just like that. That is simplified as best as it can be. Let's look at another one. This one, anytime I have something that's a 25 cents, I know that quarters go into that. I always think money when I see 25, 50, 75, 350. I can break this up into the square root of 25 times the square root of 3. This is a perfect square. So I know that 25, the square root of 25 is 5, and there's nothing I can do with the square root of 3. So my final answer is 5 times the square root of 3. We're going to try one more. Oh, this is a big one. 216. I want to find out what the square root of 216 is. Well, it ends in a 1/6. It ends in a 16. So you know what I know? I know that 4 goes into this. And 4 is one of those perfect squares we talked about. So I'm going to separate this into 4, square root of 4, times the square root of 54. Because 4 times 54 equals 216. Well, I know the square root of 4 is 2. And 54, I can break down. There's a perfect square in 54. It's 9. 9 times 6 gives me 54. So I'm going to continue to bring down the 2 because it can't just disappear and go home. And now the square root of 9 is 3. And now I'm faced with just the square root of 6. Is there anything in the square root of 6 that you could break down? Are there any perfect squares in there? Are there any things that you can do? The answer is no. So my answer is going to be, multiply those two together, 6 times the square root of 6. You're up. Answer this question and you'll put it inside the Edpuzzle. Try this problem. Try this problem. How we doing? Try this problem. Try that problem. Did you get that answer? Number 9. Here's the answer. Number 10. And there's the answer. If you have questions, make sure you take a look at any of the other videos that I have posted on the Google Classroom, and have a great spring break.